where life could have taken hold? Or could such an environment have existed at some point on Mars, where water and key chemical building blocks could have come together in a way that could support the smallest, most basic forms of life? The Mars Science Laboratory rover, NASA's new robotic vehicle for exploring Mars, is heading to the Red Planet to find the answer. So, how does a robotic rover try to find answers? By copying what its human creators do. On Earth, geologists might check out a map, drive out to a remote location, and hike to a possibly hard-to-reach spot where they could see layers of ancient rocks, like in the walls of a dried-up riverbed or the sides of a canyon.
MSL is an incredible rover because it has an amazing ability to move around, and we're going to need that because we're going to have to go into some tough-to-reach places. It can travel at least 20 kilometers, probably further. We're going to be able to land in a safe place and go beyond that to where the really rough rocks are, which is where all the good geologic clues are that tell us about the early environmental evolution of Mars.
In the hunt for evidence of life on Mars, geologists first have to determine if certain conditions were right. If the rock record shows evidence of certain minerals and organic molecules, the chemical building blocks on which all life is based.
So what MSL would be able to do is it would drive up to this outcrop, and it has a drill that's about a centimeter in diameter, and we would instruct the rover to drill a hole in the rock, and then the powder that comes out of that would then travel back into the rover, and it would be split, and it would go into the two instruments that would analyze the powder. One would give us information on mineralogy, and the other one would give us information if there were any organic molecules in here. It's really as close as we can get to putting a field geologist on Mars.
And like any good geologist, the Mars Science Laboratory rover carries a full pack of gear for the trip. On Earth, geologists use tools like compasses, rock hammers, and hand lenses to explore the environment and study the rocks. They might even do a simple acid test to see what the rocks are made of. The Mars Science Laboratory rover carries a whole laboratory with it wherever it goes. It's much bigger than any rover sent before, about the size of a car. That means it can carry a lot more advanced instruments.
We've got a laser called ChemCam, and we're going to be able to look at rocks that are on the walls of outcrops or in positions where we can't really get to it. And we'll be able to shoot this laser beam and look at the light that's reflected back to us and get some sense of the chemical composition of things that we might not be able to touch.
All these capabilities will help scientists understand the history of these remote areas.
One of the questions that people most often ask is whether or not life is unique in the universe in our solar system. And the short answer to that is we don't really know. And the only way we're going to figure this out is to leave our own planet and go explore other solar systems as well as planets within our own solar system.
Could Mars have had an environment capable of supporting life? The Mars Science Laboratory rover is taking all the tools it needs to try to solve this mystery. If all goes well, at the end of its journey, the rover will have taken us to places on Mars we could never reach before, given us a glimpse back into the history of the planet, and maybe even shown us another planet where life could survive.